Hello everyone. Today's thought for the day is, let me remind you of the famous saying given by the youth ambassador of India. That is, arise awake and stop not till the goal is reached. Can you name him? Who said it? Who said it? Yeah, correct. Swami Vivekananda, the youth ambassador, and also his birthday celebrated as the National Youth Day, said the saying, there may be many struggles while finding our goal, while reaching our goal. But also, I'd like to say another quote. We may be facing many struggles in achieving our goals. Please don't, please don't make what we can't do interfere what we can do. Please know what you can do and achieve your goals. Do not let what you can't do interfere what you do. Thank you.
Find V Thevenin, R Thevenin, maximum power. Maximum power. So we have to find V Thevenin. V Thevenin means we have to find voltage, open circuit voltage across AB we have to find. Here, how many nodes are there? Because current source is there, that's why we cannot write KVL. Sorry, we cannot write KVL. We can write only KCL. That too, we cannot convert this current source into voltage source. If you are able to convert this into voltage source, then we can write KVL. Here, we cannot convert this current source into equivalent voltage. Voltage transformation is, source transformation is not possible. That's why we have to write KCL only. That is the first step we have to identify. Here, we have to write KCL. No other go. How many junctions are there? How many junctions are there? This is one junction. We can assume it as a reference junction because this negative terminal is connected. That too, this is connected to B. That's why we can assume it as V reference. One junction is assumed as reference. Any other junction? Here one junction is there. That is V1. Is this junction? No. Because we can say this point as A or this point as A. Even if we extend this, this point is A only. If you mark here A, this point also A only. That's why it is not junction. It is not junction. This is another junction. This is another junction. Am I correct or not? Because three paths are meeting. But we know the voltage at that point. But we know voltage at that point. What is that voltage at that point? 10 volt. That's why no need to mark as a junction. We know this voltage, that is 10 volt, we know. That is V2 equal to 10 volt, that we know. V2 equal to 10 volt. At this junction, the voltage is 10 volt. So unknown voltage V1 is there. If you know V1, we can find voltage at A. If you know V1, we can find voltage at A. So to find voltage at A, we must know V1. Now we will write KVL. For that, what is the direction of current? Let us assume that V1 is greater than reference. That's why current direction is this way. We will assume that current direction is V1 to 10 volt. That's why this is also this way. So V1 is greater than 10 volt. We are assuming what is there? We do not know. But let us assume. This is, let us assume that this is also, let us assume this is incoming. This is incoming. But we know the current at 5 ohm. What is that current at 5 ohm? Current at 5 ohm is 5 ampere. That's why no problem. Current through this 5 ohm is 5 ampere. So incoming current. That's why incoming current is 5 ampere. We can write immediately. Here outgoing current, what is that current through that? Minus, why minus? Outgoing current. V1 divided by 3. This is reference equal to 0. Therefore, V1 minus 0 is V1 divided by 3. This is also outgoing current. That's why minus, why I put minus? Outgoing current. Minus V1. V1 is a direction of current is from V1 to 10 volt. V1 to 10 volt. That's why V1 minus 10 divided by 6. V1 minus 10 divided by 6 equal to 0. Any other current in that junction? No, that's all. So let us take 6 as LCM. If we take 6 as LCM, what you will get? 30 minus 2 times 2V1 minus V1 plus 10 equal to 0. So minus 3V1 equal to minus 40, or V1 equal to plus 40 by 3. So at this point, the potential at this is 40 divided by 3. Am I correct or not? 40 divided by 3. We know B equal to 0 volt. If you know the voltage at A, we can say Thevenin's voltage. If we know voltage at A, we can say Thevenin's voltage. At V1, voltage is 40 by 3. At V1, voltage is 40 by 3. We are from V1 to A, how we are traveling? We are traveling against current direction. We are traveling against current direction. Am I correct or not? Because we assume that current direction is from A to V1. We are traveling against current direction. Therefore, VA equal to, what is the base voltage? 40 by 3. 40 by 3. We are traveling against current direction. That's why plus, what is the resistance? 5 ohm. What is the current? 5 ampere. That's all. So 40 by 3 plus 25. That is equal to how much? 115 divided by 3. 115 divided by 3. 75 plus 40. So 115 divided by 3. So V Thevenin equal to, therefore VAB equal to, B equal to 0. Therefore VAB equal to 115 divided by 3 volts. 115 divided by 3 volts. That is equal to V Thevenin. We got V Thevenin. Now we have to find R Thevenin. How to find R Thevenin? 6 ohm, 5 ohm, 3 ohm. This voltage source is short circuited, current source is opened. That's all. Across AB. 6 and 3 are in parallel. Therefore, this is R1, parallel combination. 6 parallel with 3 ohm. Therefore, R1 by R1 equal to 1 by 6 plus 1 by 3. 6 inverse plus 3 inverse equal to inverse. Equal to how much? 2 ohm. Okay. So we can draw the circuit like this. This circuit becomes, this parallel combination becomes 2 ohm. This is 5 ohm. Therefore, across AB equal to 7 ohm. Therefore, Thevenin circuit is 115 divided by 3 and 7 ohm across. That is the RS. What is load resistance? 7 ohm. So we can find the maximum power. We can find the maximum power.